Hi and welcome to today's lesson. Today's lesson we are going to be looking at endothermic and exothermic reactions, okay? So by the end of this lesson I hope that you can identify some endothermic and exothermic reactions and know what they mean, identify some examples and be able to look at data and analyse whether it's an exothermic or endothermic reaction. So what do you think they mean? Exothermic and endothermic reaction. If you're following along with the worksheet that's either attached in the comments in the video link or with the lesson, then can you write down what do you think exothermic means and what do you think endothermic means? I've given like a visual clue just here on the slide. Exo, endo, entrance. You got an idea? Any idea what you think they might mean? Just pause the video and have a little think. Okay, write down something. No one's going to know if you're right or wrong at the moment. Just have a go. Get your brain working. Right, just to start the lesson, what we'll do is some retrieval practice, okay? This is a topic you've done recently, so pause the video, have a go at these 5 questions. Try and put something down again. It's about activating those brain cells, getting them going, thinking about these questions, drawing it out, even if it's just some little bits, it's starting to come together. So pause the video, have a go at these questions, write something down. Don't just look at them and think, maybe I know them, maybe I don't. Write something down, pause the video, and we'll check them in a minute. Okay, so you should have paused the video. You should have answered these questions. Maybe you used your notes. It'd be great if you didn't, but if you had to use your note, that's okay. It's better than not doing them. You need to be starting to bring that information from the back of your brain forward, okay? So these are the answers. Okay, you can check it, pause the video, you can mark them, you can go back to the questions, rewind the video, have a little look. Okay, so what we're looking at is endothermic and exothermic reaction. So I asked you to have a think about what those terms meant. Hopefully that was percolating around in your brain. So exothermic reaction is a reaction that transfers energy out of the reaction into the surroundings. So it's a reaction that actually heats up. Okay, so a reaction that energy is released from the chemical reaction, whereas an endothermic reaction takes in energy. It requires energy in order for that reaction to take place. It actually could cool down. Okay, so why do you think I've color-coded those words? Because endothermic reactions actually cool down because they're drawing energy out of the surroundings. They'll start to feel cooler, whereas exothermic reactions are hot and they release a lot of energy. Big reactions. Okay, so exothermic reactions, the temperature will increase. Examples: combustion. Remember that's a word for burning, but we need to start using the words combustion, neutralization, oxidation. Everyday object, hand warmers, those ones, you click them maybe or shake them, they release heat. Chemical reaction that release heat. You might have seen these self-heating cans. I haven't seen them around recently, but they are like coffee drinks, right? And you, when you break the seal, they heat up. Brilliant, taking a hot coffee somewhere. Endothermic are reactions that cool down. So we're talking about sports injury packs here, like the ones you snap and they cool down. We're not talking about ice packs that have been in the freezer. We're talking about ones that you make a reaction and they cool down. So the ones that sports players may be carrying in their bags. Thermal decomposition, photosynthesis, there's a temperature drop, energy is needed to go in. So photosynthesis, energy is needed to go into the reaction in order for that reaction to take place. Energy goes into it, light energy goes into that reaction. So energy is needed for that reaction to take place. Okay, so combustion, heat is given out in a combustion reaction, so it's an exothermic reaction. Okay, fuel and oxygen are combined to produce carbon dioxide and water. Okay, can you write down, maybe pause the video, you can write down the symbol equations. You could use a fuel like methane. Can you remember what methane is symbol? Write out a balanced symbol equation for that reaction. Right, remember oxygen's diatomic, O2. Okay, food cans, self-heating, like we just talked about the coffee can, they transfer heat energy into the surroundings. So again, they're exothermic. In order to make ice cubes, water has to be cooled. Energy is taken away from it. So if energy is going away from it, then it's exothermic. If energy is leaving it, okay, it's exothermic. Okay, right, so let's have a little go yourself. I'll just move my head. Okay, so look at the table. I know it says above, but it's actually below. Look at the table, complete the data. A sports injury pack needs to lower the temperature by 7.5 degrees Celsius. Estimate the mass of citric acid that needs to be added to 10 grams of sodium hydrocarbonate in order to achieve this. So this is on the worksheet if you've got the worksheet. Okay, so first of all, what you need to do is work out the temperature difference. So complete the table, work out the temperature difference. I'll pause it here. Okay, and then you need to estimate how much citric acid is needed for to be added to 10 grams of sodium carbonate. So it says up here 10 grams of sodium hydrocarbonate. Okay, so how much needs to be added if we want it to cool down by 7.5 degrees? Well, let's have a little look at the answers. So you should have got the temperature differences like this. I'll just move myself back over here. Okay, temperature differences like this. So how much would we want if we want to lower it by 7.5 degrees? Okay, so 7.5 degrees, if it was 7 degrees, then we would suggest that we would need to add 7 grams of hydrogen carbonate. Okay, if it was 6, if we wanted to cool down by 6 degrees, we'd add 7 grams of hydrogen carbonate. If we wanted to cool down by 7.5, it would be right in between 6 and 8, which would give us 7 grams of hydrogen carbonate. Okay, here's another exam style question. I want you to have a look at this and decide if it's endothermic or exothermic. Again, it's on the worksheet. Okay, have a little think. Try and explain your choices. Is it endothermic or exothermic? Okay. Pause video, have a go. And finally, this question here, is graph A endothermic or is it exothermic? So go back to those definitions, have a little look. Is it endothermic or exothermic? Okay, so by now you should have gone through, we should have identified the terms, and we should be starting to be comfortable with identifying whether reactions are exothermic or endothermic. Okay, so have a little go through it. Congratulations for turning up. Congratulations for completing your work today. Well done.